Greetings, I'm Squared here. Today we're going to talk about solving a system of equations where one of the equations is linear and one of them is quadratic. So first we want to remember what solving a system means. It means where the two graphs intersect. So we're looking for those points. So you'll see that in this particular graph there are 2 points where it intersects. Sometimes that happens. In fact, most of the time probably in the problems you'll get it'll happen. But you have to remember that it could be that the line goes like this and that they never intersect. You know, it could go like this, or it could be that they intersect twice, or it could be that it just hits it right there once, or right here once. So there's 3 possibilities. We could get one solution, no solutions, or 2 solutions. So we want to be aware of those possibilities. So remember that the answer is going to be 2 points, an x and a y. So you might think you're done because we're going to substitute and you might find x or 2 x's, but remember those 2 x's are just x's to 2 points, and then you have to plug them back in to find the y's. So let's get started. Okay, so it says remember that all the answers will be points, so you'll need an x and a y. Okay, so what we want to do is use substitution. That's what we're going to do. So if I know that y is equal to y, then anytime I see what's equal to y, I can plug it back in. So that's a little substitution. I'm going to rewrite this equation, the x squared plus 3x minus 2, but instead of y, I'm going to substitute what y equals. And then it's a quadratic equation. I've got to get it in standard form and then choose one of the ways that I want to solve it. Remember, we learned 5 ways. We're not going to do graphing on this one. So x squared plus 1x minus 2. So that's what I get when I subtract 2x from both sides. So when I look at this, I think, are there 2 factors of negative 2 that add up to 1? Because I could use factoring. Well, positive 2 times negative 1 gets me a negative 2. And if I were to add them, I would get a positive 1. So that means it's factorable. So I'm going to factor. I'm going to say x plus 2, x minus 1. I'm going to check it. 2x minus 1 is 1. That's true. That's negative 2. Yeah, so I'm good. So now I just need to find my x's. So in this case, what makes this one 0 is x equals negative 2. What makes this one 0 is x equals 1. Hopefully you remember us doing this. But remember, my solutions are points. I've only found the x's. So I know now that I have 2 solutions because I got 2 x's, and that the first x is negative 2 and that the second x is going to be 1. But now I need to find the y's. So I take this equation, y equals 2 times x from up here, and the first time I'm going to plug in my negative 2 to find the y for this point. So that's going to be negative 4, so I know that this is negative 4. And then for this one, I'm going to plug it in 2 times 1, which is 2, and so I know that that's the answer for this one. So these are my 2 solutions, or the 2 places where this line and this parabola intersect. Okay, so next one is this one. So again, do you see the y's? I know that both of those are equal to y, so I'm just going to substitute this in for that y. So I say 14x plus 5 equals 7x plus 12. I forgot my 7x squared. There we go. So it's a quadratic. I need to get it in standard form. So I'm going to subtract 14x from both sides along with my 5 from both sides, and then I'm going to combine like terms. I get a 0. So we want standard form with a 0 on one side. So I'm going to get negative 14x because there were no other x's, and 12 minus 5 is 7. So I'm going to add 7. So it's quadratic. I could factor out a common factor. I always like to check factoring first. So I notice that they're all multiples of 7. So I'm going to just divide or factor out a 7. And then I'm going to see if there are 2 factors of 1 that add up to negative 2. Yep, negative 1 and negative 1. So now I know that it's 0 equals 7, x minus 1, x minus 1. And again, I'm going to check. Negative 1 times negative 1 gets me a positive 1. Negative 1x plus negative 1x gets me my negative 2x. So I know that those are the correct vectors, and then I set each one equal to 0. Since they're both the same, I get one answer. That means I have one solution. It's not my answer, but it's the x-coordinate of my answer. To find the y-coordinate, I'm not going to get 2 solutions because the equation only produced one, x, so I get 1 point. and I can just plug it back in here. So I could say 14 times 1 is 14, plus 5 is 19. You should be able to do that here too if you wanted to plug it in. 7 times 1 squared plus 12 is still 19. 7 times 1 plus 12 is 19. It wouldn't matter which one. I just usually choose the linear one because it's easier, but always check, especially if you're on a quiz or a test, to see if that works. Okay, it needs to work in both. Let's try a couple more. So on this one again, I'm going to substitute x minus 3 equals 1/2 x squared minus 8x plus 13. The 1/2, little fraction there, we want to make sure that we recognize that. So I'm going to get everything on one side first. So I'm going to subtract my x and add my 3. And I'm going to get 0 equals 1/2 x squared minus 9x plus 16. So there's different ways you can solve it again, but if you just want to use factoring, you can. But I'm going to switch it up this time. I'm going to use the quadratic formula. So x equals the opposite of b, or negative b. B is negative 9, plus or minus the square root of b squared, that's 81, minus 4 times a times c, all over 2 times a. So I'm going to find this discriminant first. So half of 4 is 2, and 2 times 16 is 32. So I'm going to get x equals 9 plus or minus, now that's 81 minus 32. So 81 minus 32 is a nice perfect square, which is nice because then 2 times 1/2 is 1, because then we don't have irrational numbers. So this goes into 9 plus or minus 7, because the square root of 49 is 7, over 1, which we really don't need that anymore. So 9 plus 7 is 16. 9 minus 7 is 2. So those are my x's, but remember, I'm not done because I need points. So I know one of my points has a 16x coordinate and one of my points has a 2x coordinate. And the easiest one to plug it into is this y minus equals x minus 3. So the first time I'm going to put a 16 in here and subtract 3, and the next time put a 2 in there and subtract 3. So now I know that the 2 points where that parabola and that line meet are x 16, 13, and 2, negative 1. Right, last one. Pause and do it by yourself. Then you can come back and see if you're right. So again, we're going to use substitution. These are really easy ones. So this is Algebra 1 level. Obviously, they get harder when you get to Algebra 2, and you might have some more fun with that. But for us, they're going to be pretty easy, and I think all of them are integer answers, so that's nice. So we substituted. Now we need to move everything over. So minus 13 plus 2x, and we get 0 equals negative 2x squared plus 8x minus, what is that? 3, 6, and yep, 6 and 7 are 13. So notice again, I noticed that they all are divisible by 2. So I can factor out a negative 2, or you could factor out a positive 2. When you're solving, that doesn't really matter because this number out here you kind of ignore because it's not able to be a factor. So it just makes it easier for us to factor. So I'm factoring out a negative, so I have to be careful because I've got to change the sign here and change the sign there. So all of the signs change: negative, positive, negative, positive, negative, positive. So now I find 2 factors of 3 that add up to negative 4, and that would be x minus 3 and x minus 1. So now I know that my factors are x equals 3 and 1, and so my x coordinates are 3 and 1, and I plug them back into the 13 minus 2x, because that's what y equals. So if I put a 3 in there, that's 13 minus 6. So that would be 7, I believe. And put a 1 in there, 13 minus 2 is 11. So those are my 2 x, the 2 points where the line and the parabola meet. So that is how you solve systems of equations where they're both solved for y and where one is a parabola and one is a line. So good luck with that. M squared signing out.